Hi, welcome once again, Dave Sclavi, Giselle. We're here making stuffed cabbage in Dave's live steam kitchen. Still making the steam. There it is. Look at that steam coming up there. Beautiful. That's the cabbage boiling. Mae's over here. Giselle's getting the meat ready. And stuffed cabbage is like a Hungarian thing, but somehow or another the Italians took it over. I'm Italian, Giselle's Italian. Somehow the Italians took it over, and they make a pretty good stuffed cabbage. So we're going to have that a little bit later for dinner, and we're going to have a little rye bread with it. It's going to be beautiful. Anyway, this video is going to be about my automatic air brake system that I keep talking about, and I have a lot of faith in it. This summer, sometime this summer, I'm going to make an actual video of it actually operating and show the advantages of it and how it works and so on, the safety features of it. And but for right now, I'm going to do a little bit a board diagram and show the components and how they operate and how they function in the system. So we're going to go do that now, and then we'll see you in a little bit. All right. Well, now we're going to cover the basics of the air brake system. It's really nothing different than what George Westinghouse actually designed, or the Westinghouse company in later years actually designed. It's designed after the H6 brake. Okay, to start off, obviously, air compressor. Now, whether you use steam, and trust me, there is no 1.5" scale steam compressor that will compress enough air to operate this system. I have one on the engine, but anyway, air compressor, being electric, what I use, or whatever. Main reservoirs, whatever, how many you have, it doesn't matter. I have a 5-gallon tank, and then I have some on a locomotive, and then comes through here, and then this is what's called the distributing valve, which distributes the air pressure here through the lines. The green is the equalizing reservoir. This will be the automatic brake. This will be the independent brake handle. This is the automatic brake handle. These are the two duplex gauges, 2 hands per gauge, that means. And this would be a triple valve on the tender. This would be a triple valve on every car. One for every car. And this piece here, of course I'm going to go explain each one of these parts. This is what's called a shuttle check. I'll explain that. That's important. This would be what's on the tender. This would be what's on the locomotive. And this cylinder would be on every car. The equalizing reservoir, that's important. I'm not going to get into the mechanics of the valve, but basically what it is, very simple, is a regulator. It regulates air, just like an ordinary regulator you have in your shop. It's no different. What I do is I set this so it's 70 pounds of air in this tank. When this is set to 70 pounds, this allows the diaphragm here, which I'm drawing as a line across, to open up and allow 70 pounds of this 105 to 150 pounds of air pass through here into the blue line, which is the train line and the tender and so on. This is all the blue, solid blue, all blue, is the train line, and that's set at 70 pounds. And of course I set the triple valves to work at 70 pounds. Well, that's another story. Okay, so as long as that maintains 70 pounds, this is going to maintain 70 pounds. If you change this, meaning 65 pounds, that's going to open up the valve. It's going to open this up. It's going to release pressure on this side. It's going to allow 5 pounds of this air here, not this side, but this air, to pass into the exhaust, which is on the bottom, and reduce the blue line now to 65 pounds. Okay? And so on and so on. 60, 50, emergency, which is about 50 pounds. Emergency. You go into emergency, brakes are locked. You're not moving that. Right, now this is the independent. Now what that does is it's zero pressure when it's off, and as you apply it, it increases the pressure. Same as it. Just take an ordinary regulator you have in your shop and start out zero, and you turn it and it goes up to 5, 10, 15, 20 pounds. It does the same thing here, except you got a handle on it. Okay, and all right, so you have zero pressure, and then as you increase it, 5, 10, 15, 30 pounds, I have it set. 30 pounds, the wheels are going to slide. There's no way you're going to move that. No way. 30 pounds. Now on the K4 here, I have every wheel on the entire locomotive has brake shoes. lead truck, main drivers, trailing truck, and the tender. All the 8 wheels of the tender. We have brakes on all. That's the way the Penske did it. I did it the same way. By the way, in case you're going to say, well, the wheels are going to slide on the Pilot, I have it set so that's delayed. The delayed pressure. I have a choke in there so the pressure comes on gradually. So as the train's stopping, locomotive's stopping, it then puts on the brakes. Don't jam them on. Here, let's talk about this channel check. This is what's on the tender. Now the tender on my locomotive, on my trains, acts as another car when I use the automatic brake. When I use the independent, it acts as the independent, as one train, one braking system. If I put on 5 pounds of independent air, it's going to go 5 pounds into the tender. If I use the automatic brake, the tender is going to come on, the engine's going to stay on at 5 pounds that I originally put on there. And if I want to, what's called, engineers out there will know, bail off. In other words, you're dumping the air on the engine. What that does is it pulls the train a little tighter when you're coming into a stop. It like the downgrade, you know, it just kind of keeps the tension off. Now, the way the shuttle check works is you have 2 sources of air. In, this would be out to wherever you're going to go. Okay, so there's a little check disc in there. It's a disc, actually, and whatever pressure is greater, it slides to one side or the other. So if the pressure comes in here and that's greater, it slides over there, goes out. If the pressure on this end comes greater than this pressure, pushes the other way, and it goes to the cylinder. Like several weeks ago at the New Jersey Live Steamers, we had a train separation. Steve Bertina was on the first car behind the engine. Train separated, the world came to an end. The locomotive, the 1361, went about another 3 feet. Brakes came on, just the momentum carried it that far. The tender brakes locked up, stopped the locomotive, the car stopped, everything comes to a halt. Right there. No problem. Now I lost all the air in the main reservoir, and I'm going to work on that. Big John suggested that we use maybe a choke or some kind of a flow check or something that I won't dump all the air, because when I had to rehook it up, I had to wait for the air. This would be, anybody out there knows air brakes, this is chamber D. Chamber D. Now, let me explain that. The reason for the auxiliary reservoir is quite simple. Back in the day when they had the old 440s, you know, out there in the West, the old West, they had 3 cars. They've made a brake application, if they had air brakes then, I guess they did, automatic air brakes. They put the air brake on, made a brake pipe reduction. Almost immediately, the pressure dropped and the brakes would come on. As the trains got larger over the years, hundreds of cars, the brake pipe is 2.5 inches or 2.5 inches in diameter. So when you made a 5-pound brake pipe reduction, it took quite a bit of time for that brake line, the train line, the whole entire mile-long brake line, to evacuate that 5 pounds. So the train started, you know, it took a longer time for those brakes to come on. So as the guy's riding down the railroad and he's watching the signals, doing whatever he's doing, looking off, first thing you know, bingo, he's down to 10 pounds and he's not even paying attention. All right, so now you've made too much of an application. Okay, so what they did was they come up with this little tank, and of course on a locomotive, the little tank is about that big. But on my locomotive, the tank is only about little tank like that, about the size of a small jar. And I'm making the brake pipe reduction in here. I'm making a 5-pound reduction in here. That automatically will evacuate this line to match this tank. I don't have to look at it. I have a detent on my lever. As I come back with it, I hit that detent, I hold it there, that's 5 pounds, and the brakes just come on, and that's what's called the service stop. They just come on gradually, and it's just like driving a car. You don't come up to traffic like jam your brakes on, you start to brake gradually. It works the same way. You put it on there, comes to a beautiful stop. Now anybody that's ridden on my trains can say, wow, those brakes really work good. And they do. They work great, and I'm major advocate of using these brakes. I don't like vacuum at all, and a lot of guys at PLS use vacuum, and it's quite successful. And it is an easier brake to operate, to build, and it's less expensive. But you don't have the fail-safe with it. It's either on or off. With mine, I had the fail-safe, which is the major reason for doing it, and it works prototypically. It works exactly like the prototype of its full-size brother. It works exactly the same. And I've never had a problem with moisture, because it's all the triple valves and everything are all done with diaphragms. So they're rubber diaphragms, and moisture really doesn't affect it. Well, hope you enjoyed the explanation of the air brake system. I developed it about 1985, and it took me quite a while to perfect it, and just recently I've been able to miniaturize it. So that's been the big difference in being able to bring it out for inch-and-a-half scale. So if there's any questions, please email me, and I'll be glad to answer them for you. I'll try to get any pictures up there. Right now we're having a stuffed cabbage. Well, I'm telling you, this is great stuff. And we're going to have a little wine with it. It's a cheap bottle of wine, a $5 bottle, but after a couple of drinks, what's the difference? Nobody knows. Nobody cares. So here's to you and your live steam projects. We'll see you again on the next video.